This is the screencast for section 2.8, example 3. We're going to solve the polynomial inequality graphically, and example 3 is set up one way, and then if you can see, the now try problem is set up a different way in that example 3 has a function on either side, and example 13, exercise 13, has the whole polynomial set equal to 0, or, well, set greater than or equal to 0. So I'm going to do the two problems two different ways. One way, one the other way, and you can choose which way is better for you, up to you. So first, in example 3, I set the left side in y1 and the right side in y2. If I am looking for when the left side is less than or equal to the right side, I need to find out when the right side is higher than the left side. So when the left side is lower. If the left side is less than, I need to know when y1 is lower. The right side is a line, so I need to know when the curvy one dips below the line. So I'm going to go to the graph. And you can see that I have 3 points of intersection. One here, and one here. Again, I'm looking for where the curvy one dips below the line. So that's going to be here up to this point because it was or equal to. Then here, including those 2 points. That is where the y values, the output of the left function, will be less than or equal to the output of the right function. Those are the x values, so when I plug in those x values to the left side, so like if I plug in -5, the left side is going to be very negative, the right side is actually going to be very positive. So any x values I plug in on these intervals are going to produce y values that are smaller for the curvy function than they are the linear function. So all I got to do is find those intersection points, and you can do that on your own. So now that I've found these intersection points, I can state the intervals where intervals of x values, where if I plug them into the left side and the right side will be less than or equal to the right side. That would be from -infinity to 0.32, including that value because it was or equal to. Then between and including 1.46 to 4.21. Now, as I said before, number 13, the now try problem, I'm going to do a little bit differently. The left side function is x cubed minus x squared minus 2x, and the right side function is just 0. Well, y equals 0 is the x-axis, so technically all I'm looking for are x values that make this function 0. I'm looking for the zeros, and my calculator can find those for me as well. So I'm going to graph, find those zeros using my calculator. And now the problem is asking for where is this polynomial greater than or equal to 0, so above or on the x-axis. And that occurs from the x values -1 to 0, including both of those because it makes the polynomial equal to 0, as well as from the x value 2 to infinity.